Hi, 8th grade parents and students. Now we're in Module 5. So let's look at this first page. This is optional, but it's kind of a good way to get you started thinking about proportions because this chapter is about proportional relationships. So I would encourage you to do that, but it's not required. This page, the Are You Ready, is a good idea to do that because that'll tell you if you need to go back and review any concepts or skills that you'll need for this module. So do the Are You Ready? And then you can move on to the next page. So here's lesson 1, and the I can statement says, determine the slope of a line and use it to find additional points on the line. So this Spark Your Learning is a good idea to do that. It says a line passes through the origin. So here's the line that they're talking about, and here's the origin. Two right triangles each have one side along the line, line here, and another side along the x-axis. And so you can see the two triangles that they're talking about right there. How is triangle OAC related to triangle OBD? So use your tools, your protractor, your ruler, measure the angles, the sides, the lines, and tell how those two triangles are related. Then you can move on to the build understanding. So if we look at the build understanding, number 1 says points on the line represent the vertical and horizontal distances a person would travel while climbing the path before steps were built to make the climb easier. So they're going to be referencing this graph here. Write a sequence of transformations that maps one triangle onto the other to show that triangle OBC, so this triangle here, is similar to CDE, the smaller triangle here. So what transformations had to take place so that you could map those two triangles one onto the other? So you may have to go back to modules 1 and 2 to look at the different transformations that we learned. And also let's look at this vocabulary that might be helpful. The hypotenuse of a right triangle is the side opposite the right angle. The legs of a right triangle are the sides adjacent to the right angle. So in this triangle, you can see this is the right angle. So this side opposite that right angle is the hypotenuse. Here, this small little angle here is the right angle. This would be the hypotenuse opposite that. So if this is the right angle here, this would be a leg, this would be a leg. And again, if this is the right angle here, DE and CD would be legs of that triangle. So let's look at B. Complete the following based on triangle OBC and triangle CDE. So they give you some things. Length of OB over the length of CD equals the length of BC over the length of DE. BC, yes, DE, sorry. Okay, so what they want you to do here is fill in the box. So they've said this length of CD is 1, this length of DE is 3. So one thing you need to do is kind of look at this graph and make sure that the scale makes sense with what they're saying. So you'll fill in here what is the length of OB, and here what is the length of BC. And what they're showing you in this problem overall in B is they're kind of getting you started on making a proof where you're proving something going through steps. So they tell you in this first one that this is true because corresponding sides of similar triangles are proportional. And then so when you plug those numbers in, you're just using substitution. Here in this next step, so this is going to be this, and this is this again, so you'll fill in those same numbers. And then you have to look at what they did here. They multiplied both sides of the equal sign, both sides of the equation by 1/6. What property tells you that you can do that and both sides will remain equal? So then in this next step, you have the result of this here, the result of this part of the equation here, and that gives you the rise over the run. And so that's, they're telling you they just multiplied there. So go ahead and finish B. And then C, it says when moving from one point to another along a line, the change in the y coordinates is the rise, and the change in the x-coordinates is the run. The legs of triangle OBC and triangle CDE can help you visualize the rise and run. So remember, these are the legs in each of these two triangles that can help you visualize the rise and the run in each case. What does part B show you about the rise to run ratios in OBC and CDE? So again, they want you to go back and see what happened here. What did you notice when you got to the end of that part? So pause the video here, work on those, and then you can go on to the next page. So now that you've finished the build understanding, you can go on and do this step it out. Number 2 says a skateboard ramp is shown on a coordinate plane. So on this one, I really encourage you to study this graph and look at what these scales most likely are. So they tell you here point P is 1, 3. So that tells me right away that this scale on this x-axis is different from this scale on the y-axis. Because here I can see this has to be 2, then this is 4, then this has to be 6, then 8, then 10, then 12, and so on. But here they're telling me that this point Q, because this is 1, this x coordinate here in this ordered pair is 1, Q is at 1. So if this is 1, then 2 spaces, this would be 2 and 3 and so on. And using that, it gets me here at 4, and so that makes sense. So every 2 spaces along this scale they're counting it as 1. So always pay attention to the scale on different graphs. So then A says a line OP passes through the origin here and point R, so it passes through here as well. The coordinates of point Q are here, so you'll fill in those. Point S are here, so that's all you'll do in A. B, does this line represent a proportional relationship? Explain. So I wrote this here for you because it may not be something that you've learned if you did a different curriculum last year. Whenever you have a graph of a straight line through the origin, all the ordered pairs have a proportional relationship to one another. So this line, because it passes through the origin and it's a straight line, it does represent a proportional relationship. So they want you to explain that. And then C, since the run between the origin and P is 1, so remember this is the run, the unit rate is equal to the rise over run ratio. Find the unit rate of the relationship modeled by the line. Complete the equation using the coordinates of point P and the origin. So you're going to use point P and the origin, and that's what you'll fill in here. This would be point P and the origin. So P would be rise over run is 3 over 1. The origin is 0, 0, and then you'll find what you end up with there. This is going to be the unit rate. So let's look at this connected vocabulary box as well. A rate is a comparison of two quantities that have different units. A really good example is miles per gallon. We talk about that a lot with cars. How many miles per gallon does your car get? So if I say my car gets 25 miles per gallon, that means for every 1 gallon of gas I have in there, I can go 25 miles. And a unit rate is a rate in which the denominator is 1 unit. So that's a good example of a unit rate as well. And so that's what they're doing here, is getting you to look at that unit rate. So let's look at D. A vertical line segment from point R to the x-axis forms a right triangle, ORS. Complete the statements to show triangle OPQ is similar to triangle ORS. So look at what they're saying and just follow along and go step by step. The measure of POQ is equal to the measure of what? So that's an angle. What angle? And then here the measure of angle OQP and angle what are right angles. So they are also congruent or similar. Then by the Angle similarity postulate that you learned previously. Triangle OPQ is similar to triangle what? So fill those in. E, find the rise over run relationship modeled by the line using coordinates of point R and the origin. So that's similar to this one here. So you're going to do that for E. And then F, describe the slope of the line, and you'll choose either equal to, not equal to, again, or constant, not constant. So we'll pause there and work on those. So now look at number 3. Points M, 2, 3, and N, x, -6, lie on the same line. The line also passes through the origin. For a line passing through the origin, what do you notice about measuring rise over run from the origin to another point on the line? So you can use some of the things that you learned here to answer A. And then B, find the rise over the run from the origin to point M. So you're going to use this one and the origin. So this would be M, and this would be the origin, just like you did on problem 2. And then C, the rise over run ratio or slope of any line is constant. Use this ratio to write an equation that can help you find the x-coordinate of point N. So they want you to find x here using this formula. And then you'll put that in there. What is x equal? Once you finish that, you can go on to the check understanding. These 2 pages are the on your own. If you feel good about the check understanding and you don't need to review, you can do this on your own. And then here, after you've done the on your own, this homework is optional if you feel comfortable with what you're learning. And then I would always recommend do the test prep and the spiral review. And so that's all for this lesson, and we'll see you in 5.2.